Welcome to lecture 23 on risk management and insurance. In this lecture, we will deal with options. So it would be best if you review the slides on options in chapter 1. This figure here I have from chapter 1. It shows the 4 possible positions in the option market. So investor may buy a call option. The investor may sell a call option. Selling a call option is also called writing a call option. Or the investor may buy a put option or sell or write a put option. Now let's just look again at the call option. X is the strike price of the call option. So the holder of a call option has the right to buy an asset, maybe a share, at the future date at the predetermined strike price, X. Now, if it turns out that in the future, at time big T, when the option expires, the share price is higher than the strike price, then the investor still can buy the share at this lower strike price, and so the investor has a positive payoff. The true value in the future is the market value in the future of the share is higher than what the investor has to pay. The investor has the right to buy the share at X, and so the investor may get a positive payoff. Now, if in the future the share price is lower than this predetermined strike price of the option, then the investor naturally will not exercise the option. So the investor surely will not pay this higher strike price here if in the market the share is cheaper, if it turns out that the share is cheaper in the market. And so the investor just abandons the option, and the payoff is 0. Now, those possible payoffs in the option market, we can now show by those 4 expressions here. Let's again look at the call option when an investor buys a call option. So if in the future the share price turns out to be more than the strike price in the call option, then the investor naturally exercises the option. We get a positive payoff. And this positive payoff is more than 0, so that's really what matters, this positive payoff. We go for the maximum here. So if the share price in the future turns out to be more than the strike price of the option, then the investor exercises the option, and this is his payoff. This maximum, that's this number here, okay, is a relevant number. So that's what we have here. If in the future ST is bigger than the strike price of the option, then the investor will exercise and get this payoff. So that's the bigger number. Now, if in the future the share price is lower than the strike price, so we have ST minus XT and ST is lower than X, then we get here a negative number. But we are interested in the maximum, and 0 is more than negative. So it's really the 0 which matters. So the investor abandons the option, and the payoff is 0. That's what's happening here. Here, the share price in the future turns out to be less than X. So S minus X gives us a negative figure. S minus X gives a negative figure. So 0 is better than negative. We go for the maximum. And so we really have here the 0 payoff. And in the same way, you can actually use those expressions to show the payoffs for the other possible positions in the option market. We have discussed this in chapter 1. Now I would like to open another file. Yeah, here it is. Now here we turn to the option pricing model of insurance. One shortcoming of the insurance capital asset pricing model is that it does not consider the possibility of ruin. And that's a bit strange. Remember, the first model of the insurance company was the ruin model, the classical ruin theory of insurance. We discussed this first, this classical ruin theory of insurance. And then we moved to the insurance capital pricing model, and in that model, the possibility of ruin is actually neglected. We never mentioned the ruin when we discussed the insurance capital pricing model. So it's just a basic, it's a very different model than the first model. Now we turn now here to the third model, which is the option pricing model of insurance. And in the option pricing model of insurance, this considers again the possibility that the insurance company goes bankrupt. So we have those three models. The first model was the classical ruin theory. The second model was the insurance capital asset pricing model, which neglects the possibility of ruin. And now the third model is the option pricing theory of insurance. And here we again consider the possibility of ruin. Now let's assume that the insurance company is set up at time small t and that it operates until time big T. Now this time period may be 1 year, but it also could be more than 1 year. And we will now model the assets and the liabilities of the insurance company using geometric Brownian motions. It does not matter if you have never heard about geometric Brownian motions. I give you here a very short introduction, and then later on we have an entire chapter on geometric Brownian motions and insurance price and the pricing of options. So here, just a short introduction first. And I really assume that maybe you have not heard from geometric Brownian motions before. So dA stands for the change in the value of the assets of the insurance company in a very short time period, maybe 1 day or even less. And this change in the value of the assets has a deterministic part and a stochastic part. The deterministic part is expressed as a percentage of the value of the assets at some given date. So for example, if the insurance company has $100 million of assets, and mu A, the parameter mu A is 3%, then the assets of the insurance company will increase by $3 million over the next day. And that's fixed, that's constant. We call it a drift. We could also call it a trend. So each day we have this upward pressure on the assets of the insurance companies, maybe $3 million. But then we also have the stochastic component. The stochastic component, that's the random shocks. And those random shocks are independent random draws with mean 0 and standard deviation 1. Standard deviation 1. So we have here a sequence of independent random draws always mean 0 and a standard deviation of 1. Now, this sequence of random draws then determines, okay, here, the behavior of the assets of the insurance company over time. That's a sequence of independent random draws with mean 0 and standard deviation 1. You call it the Wiener process. Wiener was a mathematician who lived about 100 years ago, and he introduced this stochastic process. It became very popular in engineering and also in physics. And also, actually, Einstein used it in some famous papers. Now, it would be strange if the volatility of the assets has actually standard deviation 1. You see, the Wiener process has a standard deviation of 1. But naturally, the fluctuations of the assets over time do not have the standard deviation 1. It would be just by chance. And so we introduce here also a scaling factor for the standard deviation. So we multiply those random shocks here with a scaling factor for the standard deviation. And this scaling factor we again express in percent. In percent as a percentage of the asset price, of the value of the assets of the insurance company at some point in time. That's a geometric Brownian motion. It's geometric because here the trend or drift and the volatility are expressed as a percentage of the values of the assets at the given point in time. And we may have here a positive drift. Natural drift could be also negative. Mu A could also be a negative parameter. Let's assume it's a positive parameter. So every day we have this upward movement in the assets. We have this positive drift, but then we also have the shocks. And the shocks may reinforce the drift. If there's a positive shock, then it will be reinforcing the drift. But naturally, those random shocks can also be negative. And then they will offset the drift. And if it's a very strong negative shock here, then maybe the value of the assets falls at a certain day, even with this positive drift. So there is this positive drift, and there are also shocks which may be positive or negative. And the sum of the two then gives the change in the value of the assets of the insurance company from one day to the next. And the same model we apply to the liabilities. That's how it may look. So let's assume the insurance company is established at time small t, and it operates until time big T, and then it is dissolved. And maybe that's a behavior of the assets. There seems to be here a weak drift in it, a weak positive drift. It's somewhat upward drifting. But here, very important are the random shocks. So here, for example, we have a sequence of negative random shocks from the Wiener process. And those random shocks then really overwhelm the positive drift. And so the value of the set is falling. And the same, okay, here for the liabilities. Now, this insurance company here stays always solvent. You see, the assets are always bigger than the liabilities. So also here at the time when it's dissolved, the assets are more than the liabilities. And so the insurance company is solvent. But it could be that it looks like this, that the stochastic process plays out like this. And we have a lot of negative shocks here over some days. And so the insurance company gets insolvent. That may happen by pure chance. You see here this stochastic component, those shocks here, they are independent random draws with mean 0, standard deviation 1. And then we also apply here a scaling factor for the standard deviations. So it's possible that over a few days, over a number of days, we have a lot of negative shocks. And that's what we have here. We have here a lot of negative shocks. And so then, at the same time, we have here maybe also by pure chance, we have here positive shocks to the liabilities of the insurance company. So at this point here, at this time, the liabilities then become more than the assets, and the insurance company is bankrupt. And then it should no longer trade. You see companies that have more liabilities than assets are insolvent, and since they are no longer allowed to trade. Okay, so those are stochastic processes. The pattern of those stochastic processes depends naturally on the parameter mu and on this parameter here, the sigma A, which determines the volatility. So two parameters determine how this stochastic process here looks for A. And similarly here for the liabilities. Now the assets of the insurance company covers entitlements of the insurance buyers and of the shareholders. So when the insurance company is closed down, then those assets here cover the entitlements of the shareholders, but also of the insurance buyers. The insurance company has to pay for the losses that the insurance buyers have, because maybe their car gets stolen or there is a house fire. And so some of those assets go to the insurance buyers, covering those entitlements, and the remainder then actually goes to the shareholders. And here you can easily split this excess, so it's no problem here. The liabilities of the insurance company are less than the assets, so the insurance buyers get those liabilities here. Now at time t, the division of assets between shareholders and insurance buyers depends on whether the insurance company is solvent or whether it is broke. And let's now first look at the shareholders. If the insurance company is solvent, then the shareholders just get the excess of assets over liabilities. And if the insurance company is insolvent, then they get nothing. So if the insurance company is here solvent, then the shareholders get the excess of assets over liabilities. And if the insurance company is insolvent at the time big T, when it's closed down, then the shareholders get nothing. And the assets are just used, the remaining assets are just used to partially compensate those holders here of those liabilities of the creditors. So really what the shareholders have, they hold a call option whose payout at time t, when the insurance company is closed down, is a maximum of those two items here. It's a call option. They are long on a call option. So if at time big T, when the insurance company is closed down, assets are more than liabilities, the insurance company is solvent, and the shareholders get just this positive payout, positive payoff. Now, if at time big T, the assets are less than the liabilities of the insurance company, then the insurance company is bankrupt, and the shareholders get nothing. So we have here exactly the payoff of a long call option. So that's actually pretty neat, okay, to look at it this way. So when you buy the shares of an insurance company or of any company, then basically what you buy is a call option. If you also take into consideration that the company may go bankrupt. Now, it's a situation of the insurance buyers is a bit more difficult. Here. Now, the insurance buyers will receive LT if the insurance company is solvent. You see, the insurance buyers are entitled to those liabilities of the insurance companies. They gave credit to the insurance company. They bought insurance contracts, and the insurance company must now cover the losses of the insurance buyers. And it can do that if it is solvent. If the assets is more than the liabilities that the insurance company has toward the insurance buyers, then the insurance buyers just simply get their losses covered. But if the insurance company is bankrupt, then the insurance company no longer has enough funds to cover all the losses of the insurance buyers to make those payments if a car gets stolen or a house burns down. And so the insurance buyers just get the remaining assets of the insurance company, but that's actually less than what they should have gotten. But okay, that's just how it is. So insurance company is bankrupt. So they get a minimum of the two. You see here they get a smaller L less than A, and here A less than L. So they have the minimum of A or L. So it's here the minimum of A or L. That's what the insurance buyers will get when the insurance company closes down. What they really get depends again whether it's solvent. When the insurance company is solvent, they will get L. The insurance payments will be sufficient to cover the losses. So the assets exceeds the liability, so the insurance company can make those payments. And if the insurance company is bankrupt, then the assets are actually insufficient. So the insurance company will only get those assets. The insurance buyer should get the LT, but they get less because the insurance company is bankrupt. So they have the minimum here, L less than A, here A less than L. They have the minimum. And now let's add here L. And if you add L, naturally you also must somewhere subtract it. So as well as I don't have it, I don't have the quality. So let's add the L, and then I subtract the L here from AT. So I have here AT minus L. And I also must subtract here LT from the second possible outcome. So I have here LT minus LT. That gives me the 0 here. So simply what I'm doing here with this expression here, I add L in front of it, and then in the expression I subtract L. And I have to subtract L from both possible outcomes. So A minus L, and here L minus L. L minus L gives me the 0. And if you look it up in the figures that I showed at the beginning of this lecture, that's actually the payout of a short put option. That's what the writer of a put option gets. And then you can also look in that figure, a short put option is just a negative of a long put option. Just look at the figure that I gave at the beginning of this lecture. So the short put is a negative of a long put. So the net position of the insurance buyers equals the liabilities of the insurance companies, and the insurance company has those liabilities because the insurance buyers bought the insurance contracts. The insurance company must make those payments if the insurance buyers have losses because a house burns down or whatever. So the net position equals LT minus this long put option. So it's adjusted for the insolvency put. And this insolvency put takes account of the risk that the insurance company will fail. You see it's coming from up here, okay, possibilities that it's bankrupt. Okay, so that's, okay, sorry about that one. That's the possibility, or that shows the situation of the insurance buyers, what happens if the insurance company is solvent or insolvent. So if the insurance company is broke at time T, when it's closed down, then actually the insurance buyers are not fully compensated. Then the assets are not sufficient to make all the payments to cover all the liabilities of the insurance company. Then L is bigger than A. Now, if the insurance company is broke, then the shareholders, they will lose at most their shares. The liability of the shareholders is limited. That's really what's important about companies that issue shares. It's the owners of the company, which are the shareholders, they have only limited liability. The most they can lose is their shares. So the shareholders, they have the option to transfer the excess of liabilities over assets. This is the excess of liability over assets to the insurance buyers by declaring bankruptcy. And this put option is written by the insurance buyers. And the price of that put option reflects then the economic value of the risk of ruin of the insurance company. So the argument here is as follows. Let's repeat it. The liability of shareholders is limited. They lose at most their shares. And so when the insurance company goes broke, then it's really the insurance buyers who lose money. And that's what the insurance buyers lose. LT minus LT. They should get LT, but the assets of the insurance companies are less. They will get those assets when the insurance company is broke, but it does not cover all the liabilities that the insurance company has towards insurance buyers. And so really the shareholders can have the option to transfer this excess of liabilities over assets to the insurance buyers simply by declaring bankruptcy. Now that happens very often, and it also applies to other firms. You see, if a firm is bankrupt, then it has the option to transfer the excess of liabilities over assets to the creditors. The creditors will not get fully compensated. The creditors will carry the losses. The creditors get the remaining assets, but they are not sufficient to cover what the creditors should get, what the company owes to the creditors. So any company has the option to transfer the excess of liabilities over assets to the creditors by declaring bankruptcy. Now, in the case of the insurance company, the creditors are the insurance buyers. Now, some people do this actually repeatedly. Okay, Donald Trump, the president of the United States, he owned different firms, and 3 times actually firms that he owned went bankrupt. So he actually transferred the excess of liabilities over assets. He transferred it to the creditors. He pulled that option, and he used that option to do that. Naturally, okay, if you do this repeatedly, it's an abuse of the system, okay, and it will affect your reputation. So creditors, potential creditors will learn about that, and then they no longer will give money to Donald Trump. But some people can get away with that, and they do it repeatedly. They go bankrupt, and then the excessive liabilities of assets are just transferred to the creditors. The creditors lose the money. So at time t, when the insurance company is closed down, the division of assets between shareholders and the insurance buyers is given here by equation 36. We have the total assets here of the insurance company at time big T. That's what the shareholders are entitled to. It's this call option. And that's what the insurance buyers are entitled to. It's this, the insurance payment, it's this liability, plus adjusted by this insolvency put. And when the assets and liabilities follow geometric Brownian motions, then you can use the Black-Scholes option pricing model, okay, to determine the value of those options here. Now let's again look here what happens here if the insurance company is solvent. If the insurance company is solvent, then the assets are more than the liabilities. And so actually this here applies here. We go for the maximum. If it's solvent, then the assets are more than the liabilities. And so that's a value of this put option. So it's AT minus LT, that's a positive number. And that's bigger than 0. Now, if the insurance company is solvent, assets are more than liability. Then here we have a negative number. So that's a negative, assets are more than liabilities, that's a negative number. So 0 is better. So here we get a 0. And so here we have A minus L plus L. And so we get A. So you see the equation makes sense when the insurance company is solvent. When the insurance company is solvent, then this insolvency put here has 0 value. Assets are bigger than liability, it's solvent, so we get here a negative figure, and so 0 is more than negative, so we have here a 0, but still we have the LT here. So we get now AT minus LT plus LT. And so the LTs cancel out, and we just have AT. AT equals AT. Now let's assume what happens if the insurance company is insolvent. If the insurance company is insolvent, then LT is bigger than LT, so LT is bigger than 80, so we get a negative figure here. We go for the maximum, so here we will have a 0. The 0 applies here. If it's insolvent, then the insolvency put has value. L is bigger than A. Liability is bigger than asset. So here we have L minus A. So I have plus L minus L, again the L cancelled out, we just have the A, and so on the right side we get A, and here on the left side we have also A. Remember here it's a 0. So this equation really applies for both situations, versus the insurance company is solvent or insolvent. It's a pretty neat equation. And that's where I would like to stop for today. Thank you very much.